The final piece of this assignment is the GUI component, and it is in the GUI component that we draw both the buttons that we interact with and the objects that are going to be in the game world. So let's walk through that now. When we look at the Unity client, we can see that the Unity client here has an element called MyGUI. That's a game object that's been added to the hierarchy. And then I have attached a script as well. The script is also called MyGUI. And that script has several public variables. MyGUI skin, you'll recall that from our last assignment. This is a place where we can put custom formatting in to our text and our UI elements. We got skin right here from the asset store, and what we did is we used the built-in GUI. I think that's right. So we get, yeah, there we go. The built-in GUI skin. We imported that, and that gave us access to all of these different elements, including the skin, which we could then use to customize our interface, which is why my fonts are bigger and why I can use a font other than the one that comes by default. The next element we have here is a public game element that is in my script called Tower, and I have to drag some prefab element into that. This is going to be the objects that I instantiate whenever I see someone's tower. And so you can see here, down here in the bottom, I guess, you can see that, oh, there it is. This is the tower that I drop whenever I encounter a tower in the data structure that we get back from the server. Likewise, if we go back to my GUI, this element bomb ball, this is the bomb that I drop whenever I see a bomb come back in my data structure. All right, those are both defined within my script. These spaces are just defined within my script, and then I drag something here to have them drawn. The last element is something called a mesh material called new material. That new material consists of a material that I made as an asset, and I attached a special shader to it called bumped specular vertex colorer. And what that enables us to do is to change the color of a mesh by changing the colors of the vertices that are part of that mesh, as opposed to what's normally done, which is to color a mesh by applying a texture to it. Okay, so those two things are checked into the repository, that material, and then the other thing you need in order to make that possible is this custom shader. That custom shader, if you drag and drop it onto here, will create bumped specular vertex colorer. So that shader goes into the new material, and then the new material gets dropped there. And we're going to use that because when we make our mesh in our script, we're going to attach that material to it. Okay, so let's go look at the script that I'm providing for you as a template. You can use it as a starting point, and if you fill it in the places where I indicate, then you'll have a game that kind of looks more or less like mine. Depending on your ambition, you're welcome to try and do things more complicated, some other way that maybe you're a better Unity programmer and you have a great idea for how to do this. So let's go to the code and take a look at what's provided for you. Okay. This is the code that's provided. I went through and I documented as much as possible to make it as easy as possible for you guys to get this done. The first element, these are all public variables that we looked at in the UI element. These are places where you drag and drop other elements of Unity so that we can access them in the script. So we have a GUI skin, we have a tower game object, we have a bomb game object, and we have the material. The next set of items are hooks to other pieces of the Unity environment that we've seen in the previous examples in the GPS drawing assignment. So we have a connection to the camera that we're going to be moving. We have a connection to the network helper so that we can make calls to the network. We have a connection to the location, my location component, so that we can get the current location from our code. We have a connection to the gyro controller so that we can correct the gyro. so that we can set up the camera according to the gyro. Okay, the next set of things we have are elements associated with our GUI, and these are elements that are going to store the values that our users have typed in into elements on the graphical user interface. The next element is a set of a list of strings for errors. If I want to output them to my GUI, I can put them there. This set of variables has to do with camera control. The first part has to do with camera control, and then the camera control depends on your current known position. And so these are things that if you set the current known position correctly, the camera control should take care of itself. Okay, these elements here are provided by the game state. When you get the game state back, these elements will be set for you. These elements are the mesh that we're going to draw, which is the floor, which just shows you who has what territory. In the first video, this was the thing that looked kind of pink, indicating which tower owned which element. These are lists of game world elements that we're going to keep track of. So world is going to have persistent game objects like the mesh we're going to create, and temp world is going to have things that we're going to be destroying and recreating, namely the towers and the bombs. This owner colors is a data structure that enables us to map from the name of an owner to a color so that we can draw the mesh in a color that's consistent with a given owner. Alright, so the first set of functions here are things that connect us to the rest of the Unity environment. I provided one example here, check the network helper. That assigns the network helper to that bit of code to that object elsewhere in the Unity environment. You'll need to do the same for location, and need to do the same for the gyro controller, and you'll also need to do the same for the camera. The camera doesn't require I didn't put the camera in a separate function. Okay, in the start function, I go ahead and provide code to initialize the errors for you, to make sure that the GUI skin has been set. You need to set your UI fields to appropriate defaults depending on how you're doing your UI. You'll need to make the calls which connect the hooks to the other elements of the environment. In addition to that means those three functions above, plus you'll also need to set the camera to the camera game object. And here's where you need to make a call to the location component to set the initial values of lat long, last lat, last long, and last altitude so that the camera works. These elements for the camera, provided that you have set the camera correctly at this point, will smoothly control the camera to follow you around as you walk. Then lastly here, if you want to add default colors to this data structure, you can do that here. Okay. All right, now, maybe the next thing we should look at is, rather than looking at these functions, let's just walk through them. So this is a function that when you provide it a name, will return a color, and this is so that you can color the territories according to the owner. You can see that it uses that data structure that we had before, and what you need to do is fill something into so that when a color is requested for someone that you haven't seen before, you give them a color and put it in the data structure so that next time when this function is called with the same name, the same color is returned. This is a helper function that will add a string to your error list and debug it to the Unity console. MakeBaseMesh is a function that will create the floor for you the first time that the game state is returned. This was pretty complicated to figure out, and so I'm going to go ahead and provide it for you, and this means that you're going to end up, if you use this, you're going to end up doing something that looks a lot like what I had. You can see that you go through here, and based on the size, the number of steps in your world, and how far the world is from step to step, it creates a mesh with vertices and colors on each of those points. It creates triangles from those vertices. It initializes a bunch of data structures so that you can build a mesh from it. You can tell Unity to optimize it, and then you can start drawing it in your game world. Okay. All right. So these are all helper functions so far. Here's a callback function that you can pass to the getGameState function as the last parameter, in the network helper. And when your game state is returned from the game engine, this function will be called with this state object. And this code goes through and it parses that game state object for you so that you can do whatever you want to do with it. So first we check to see if there are any errors. And provided there are no errors, we then get the first element of our data structure, the data. If this is the first time we've gotten any game state, then MyMesh will be null, and we go ahead and we pull out the elements from our game state here that come every time, but we only grab it the first time. We keep track of them in local variables, and then we build our base mesh based on those variables that we just pulled out of the data structure. That only happens the first time we get game state. Okay, after we build our mesh, then the next thing that we do is we destroy any towers or bombs that we're currently drawing in the system, and we replace them with any new towers and bombs that we find. And this is where you can see the code gets executed, so that if we see that there in this data that gets returned, we'll see that there's a value for tower, and if that value for tower is true, then we're going to instantiate one of the tower objects that you passed into the UI via the graphical user interface in Unity. When you do that, that prefab gets assigned to this variable, and when we instantiate it, we make a copy of it at this location and with this rotation. We keep track of that by putting it in our temp world, so that next time we update the game state, we'll destroy it and then redraw it if it's appropriate. In case in between our calls to the game state it was destroyed by a bomb, for example. Similar thing we do for the bomb. If we see that there is a bomb in this given grid cell, this goes through each grid cell. If we see that there is a bomb in that grid cell, then we're going to add a bomb at the location at which we're currently located. For each one of these grid cells that we go through, we're going to set the color of that grid cell equal to the owner color that's provided by the function previously. When we set this array of colors, this is the same array of colors we had when we initially established our base mesh. After we've gone through each of our grid cells, then down here we're going to reset our vertices, we're going to reset our colors, we're going to tell Unity to optimize it, and then those objects will be in our world and we'll be able to maneuver around them until the next time we refresh the game state. Okay. This is a generic callback function that you can use for any time you need a callback from calling the network helper. And it doesn't do anything. But what it's designed to do is find any error messages that you might have and do something with it. If you want to do something with it, you need to supply that. Here's a special callback that you can use for the leaderboard. So when the leaderboard call returns, it will be passed this state. And if there are any errors, you can decide what to do with the errors there. But otherwise, there will be a bunch of results which show who the leader is. And in this loop, y.key is going to be the player, and y.value is going to be their score. And you can do whatever you want to do with that leaderboard. Finally, the most work to be done is probably here in onGUI. It's in this function that you have to draw the buttons and the text field elements that capture those things that you need to play the game. The world name, the world password, the player name, the player password, the buttons which upload and capture the tower locations, upload and capture the bomb locations, upload the code, the codes, and fetch the game state, and get the leaderboard. You can fill that out in this section here, however you'd like to draw it. Finally, in the regular draw loop, this bit of code's provided for you. This first section of code here updates the camera and moves the camera smoothly to whatever location is currently set in the last longitude, latitude, and altitude. And you're supposed to add those. So there's a freebie. You update those there. Okay. All right, so that's sort of a summary of the GUI template. This GUI template is uploaded in GitHub. You can access it the same way as the other ones, and I'll link to it from our webpage. Okay, so in summary, that's kind of it. If we walk through our Unity interface, we know the main camera has to have a gyro associated with it. The GUI has to be filled out with the buttons, and the buttons have to be connected to network calls. My location is largely provided for you. My network helper is largely provided for you. And then you have to provide a base world in which you're going to draw the rest of the world as it comes in from the game state. Put those things together, and then we'll try and play it. Good luck. If you have any questions, please post them on Piazza.